Okay, so we're going to go through some fundamental trig identities, and these are going to be things you're going to need to know and that you're going to need to know like inside and out. So the reciprocal identities we've already talked about once, about how cosecant, oops, that's not how we write that, cosecant of theta is the reciprocal of sine theta. So we've already talked about that one for sure. And that secant of theta is the reciprocal of cosine. Also, that cotangent of theta is the reciprocal of tangent. So those we've talked about a couple of times already, but those are going to come up repeatedly, and we're going to need to be able to pull those up from the top of our heads pretty quickly. We're also going to want to have the relationship between tangent and sine and cosine, noting down that tangent of theta is the same thing as sine theta over cosine theta, which means that cotangent is actually the reciprocal of that, cosine of theta over sine of theta. So those shouldn't be super duper new. We should hopefully have a little bit of that. The really, really new things we're going to have today are our Pythagorean identities. And I'm going to make a really quick note about some notation. I'm going to put it up here at the top. We're going to start seeing things with exponents on our trig functions. So we're going to see something like sine squared of theta. And what that means, that's the same thing as sine of theta, the quantity squared, which is the same thing as sine theta times sine theta. We just write it like this because then we get to cut out a whole lot of parentheses and things wind up looking honestly less messy if we put them like that. So our Pythagorean identities, and we will go through proving these today as well, our Pythagorean identities, and you're going to want to have these memorized. You're going to need them. We're going to use them a lot, but you're also going to need to like intentionally focus on these. Sine squared of theta plus cosine squared of theta equals 1. Another important one is that we're going to have 1 plus, and that's the number 1, tangent squared of theta equals secant squared of theta. One more trig identity to write down today. 1 plus cotangent squared of theta equals cosecant squared of theta. And we are going to work through and kind of prove the Pythagorean IDs today. We're going to start with this one, and we're going to prove that this is true. And that'll push us into these guys over here, and we're going to prove that these are true as well. So our very first one here, on the left-hand side, we're going to prove that tangent of theta is the same thing as sine over cosine theta. So the way we're going to do that is we're actually going to switch the right-hand side back into the way we originally wrote these trig identities with our opposite, adjacent, and hypotenuse. So coming in over here, I'm going to keep the left-hand side the same, and we're trying to get the right-hand side to be tangent. So tangent of theta equals, and I'm going to write this as one big fraction. I'm going to take sine of theta, and we're going to write that as the opposite over hypotenuse. And our cosine, there we go, is the adjacent over hypotenuse. So that's what the definition of sine and cosine say. Now, we know when we are dividing by fractions, it actually means to multiply by the reciprocal. So I can switch this, and my left-hand side staying the same. Tangent of theta, we think, is equal to the opposite over hypotenuse. That sine is still staying right there. And we're going to multiply by the reciprocal. Hypotenuse over adjacent. And hopefully we can notice that the hypotenuse values cancel out. So what we really have is that tangent of theta equals opposite over adjacent, which according to the definitions of our trig functions, that is true. My left-hand side meets my right-hand side. They mean the same thing. So it's true, and we just proved it, that the tangent of theta is the same thing as sine theta over cosine theta. Okay? So that's what I mean when I say we're going to be proving these identities. We're trying to make the left-hand side meet the right-hand side. Or on this one, we're going to try and make the right-hand side have this make sense. Okay? So this is where that notation that I talked about on the previous page is really going to come in. This sine squared theta. This means it is, we could also write this as sine of theta squared. We could also write this as cosine of theta squared equaling 1. Because then I could write each of these into their opposite and adjacent kind of stuff. So sine, remember that's opposite over hypotenuse squared plus cosine. Oh, that's not how we do that. Cosine, that's our adjacent over hypotenuse squared using our exponent laws, I can bring that in to make that be opposite squared over hypotenuse squared plus adjacent squared over hypotenuse squared. And we can see that they actually have a common denominator, so what we're going to do is combine those together. So we're going to get opposite squared plus adjacent squared over hypotenuse squared equals 1. And while that doesn't look that much better, what we're actually going to do is multiply by the denominator. I'd like to get rid of that thing. So we're going to take our hypotenuse squared on both sides. And what we wind up with is the opposite side squared plus the adjacent side squared equals the hypotenuse squared. What this is a squared plus b squared equals c squared. So we wound up actually finding the Pythagorean identity in here, the Pythagorean theorem. That's why these are called Pythagorean identities, is they're based off of the Pythagorean theorem. So we can use all of the information in here, since we know the Pythagorean theorem is true, we can use these identities to move around and solve things and work with stuff. Okay? So when we see that that opposite squared plus the adjacent squared equals the hypotenuse squared, that means we've just proved the Pythagorean theorem. Okay? Let's do a little bit more. So let's look at that tangent identity. So this time I'm not going to take it all the way down into our hypotenuse and adjacent and all that stuff. I'm going to switch this into only sines and cosines. So we're going to have 1 plus tangent squared. Remember, tangent is sine over cosine. So we can write this as sine squared theta over cosine squared theta. And we can write secant squared, or we're going to leave the right-hand side by itself, secant squared. Because we would like to make this left-hand side be the exact same as the right-hand side. So I would like to make this be a thing. If it helps, you can also switch this into our 1 over cosine squared for secant squared. But honestly, I don't want to write fractions that many times. Because what I'd really like to do is to be able to combine these guys together, which means I need it to have a common denominator. So I'm going to take this 1 and actually switch it to be I'm going to multiply it by cosine squared over cosine squared. And we're still adding it to sine squared theta over cosine squared theta. I have a common denominator, so I can add these together. So we have cosine squared theta. And my numerator is cosine squared theta plus sine squared theta. And that seems really, really familiar. If you think back to the one we just looked at, it started out with sine squared theta and cosine squared theta. So since it's addition, it doesn't really matter what order we add things in. So I can switch this around to be sine squared theta plus cosine squared theta over cosine squared theta. And we just saw in that last identity that we proved was right, that when we have sine squared theta and cosine squared theta, it equals 1. So what this really is 1 over cosine squared theta. And that really does equal secant squared theta. So we showed that this left-hand side, we never crossed the equal sign. We never did operations on both sides. We're just simplifying here. But this side does actually lead to secant squared theta. Okay? I'm sure you're probably close to the end of time in class, but I'm going to do the last one. But it's the same kind of vibe. So we're going to prove this last identity. And it's the same kind of vibe. We're going to take our cotangent squared and we're going to switch that into sines and cosines. And we're going to try and make the left-hand side match the right-hand side. So we're going to take our 1 plus sine squared theta. Oh, sorry, I have that upside down. Cosine squared. Cosine squared goes on top of cotangent. Cosine squared theta over sine squared theta. And we're going to get to common denominators. So I'm going to multiply that 1 by sine squared over sine squared. So that we have sine squared of theta over sine squared of theta plus cosine squared theta over sine squared theta. I've got that common denominator, so let's put them together. So we have our sine squared theta plus cosine squared theta over sine squared theta. And just like we saw in the last one, that sine squared of theta plus cosine squared of theta equals 1. That was the identity that we proved over here. Sine squared theta plus cosine squared theta is 1. That's what it is. So we can rewrite this as 1 over sine squared theta, and that actually does equal cosecant squared. So we can prove these Pythagorean identities using the other identities that we have, okay? And what we're going to be doing as we go through next week is we are going to be taking these identities and using them to simplify things and to solve things, okay? So I'm going to toss up the homework page with the information for 6-2A. If you haven't finished everything yet, please do so and get that turned in when we get back. And I hope you have a great weekend, and I'll see you guys later.